Okay, I just want to look at how you can find points of inflection. And first of all, what is a point of inflection? So a point of inflection is basically where there is a change in concavity. So it means where it goes from concave down to concave up, or where it goes concave up to concave down. Another time where that happens is if you do have like a maximum and you have a minimum, you notice that there's a point there where it goes concave down to concave up. Okay, so this one goes up and I go down. Now at the point in the middle there, that is where it is neither concave up or concave down. Okay, at that point there, especially on this curve here, that's where it will be at its steepest. At this one here, that's where it is actually at a stat point. But where there is a change in concavity at that particular point, that is where that point is called an inflection. Now the first two that I have here, they are also stat points. Okay, so with the stat point, y dash is equal to 0 at that point. And you notice that if you ran a horizontal tangent line along here, at that point that's where it would be horizontal. But looking at this one here, at that point, the gradient is not horizontal. So this one is not a stat point. This one is just where there is a change in concavity that's going between the maximum and the minimum. Okay. Now something that's really special about all of these points is when it is concave down, y double dash is less than 0, concave up, y double dash is greater than 0, but at the actual point of inflection, y double dash equals 0. So this is where y double dash equals 0, and when it's down, it is less than 0, and when it's up, it is greater than 0. Down is less than 0, when it is up, it is greater than 0. So, as far as inflection points, inflection is like the big family name. And it's the family name for anyone in the family where there is a change in concavity. So usually it's just in between stat points. You'll find that there is a change in concavity. And on the curve, it's basically where the gradient is at its steepest point, because it's going from like down and then it changes and it pivots out and the gradient slows down till it comes to 0. Okay, so that's one type of point of inflection. For that point of inflection, y double dash equals 0, and it is not stationary. Okay, but when it is stationary, it is also a stat point. So y dash equals 0, but it also at that point is where y double dash equals 0, and there is a change in concavity. Okay, so at that point there, y double dash will be less than 0 and y double dash is greater than 0. So whenever you're doing these points, you also have to check that y double dash changes sign. So say you got at that point that was A, you did A a little bit less and A a little bit less. Always write what you're subbing into on top, so it's y double dash. So like if you look at this one here, it went from negative to positive y double dash, negative to positive. So it will change sign, okay, because it'll be concave down to concave up. So you say therefore y double dash changes sign. And this one here you've got y double dash changes sign. So whenever you do any point of inflection, you also have to check that that happens, that y double dash changes sign. If it doesn't, then it is not a point of inflection. And an example of where it doesn't work is like, let's look at y equals x to the 4. Now if I find y dash, I get 4x cubed. Okay, if I make y dash equals 0, then 4x cubed equals 0, and x cubed equals 0 divided by 4, which is the cube root of 0, so 0. So that means that x equals 0, and y equals 0 to the 4, which is 0. That is a stat point. But if you look at this as well, if you find y double dash, that would be 12x squared. And if you put 0 into there, y double dash would be 12 times 0 squared, which is 0. So it is also an inflection point. So that means it must be, or is it? Yeah. And it would mean, you would think it would be a horizontal point of inflection. But is it? So what you do is if you check either side of that point, so you go x, y double dash, and you put 0 and 0 in there, you go 1 and minus 1, y double dash equals 12x squared. If you put minus 1 in there, you get a positive. And if you put 1 in there, you get a positive. So therefore y double dash doesn't change sign. And if you were going to sketch this, you've got this point at 0, 0, you go, that's going to be positive, concave up on that side, concave up on that side. So it is actually a minimum. And you would have picked that up if you'd put it into the first derivative, because the first derivative will just find the sign of the gradient. So y dash is 4x cubed. If you put minus 1 in there, it's negative. And if you put positive 1 in there, it is positive. So to be negative, positive, so you notice that is a minimum. So that's actually an exception. So to actually find points of inflection, they'll come up in two places. They'll come up with your stat points. Any horizontal inflections will come up when y dash equals 0. And you determine the nature, you'll get your horizontal point of inflection. But actually to find any other horizontal point of inflections, you find y double dash, you make y double dash equals 0 and you solve for x. So you might get x equals a, and then you have to test y double dash changes sign because you're checking for a change in concavity. So you need to use a table of values. So for your table of values, you write y double dash on top, and you go x, y double dash, you go a little bit more, 0. You put it in there and you're checking that it goes from positive to negative, which means concave down, concave up, concave down. Or you could also go, you've got a plus a and 0. You go from negative to positive. So that would be concave down to concave up. And that just means it's going the other way.